Yeah. So we are going to start with diffusion and effusion. See, the two term here we have, one is diffusion, other one is effusion. First of all, if I tell you this effusion, effusion is the leaking of gas, right? Like the puncture or when the football bladder burst, right? Okay. So effusion is what? Effusion is, write down. It is the process. I'll write down like this. Wait. Definition first you write down, then you will understand. Effusion is a process by which a gas under pressure, this point is important, okay, under pressure escapes from the vessel through a small opening or orifice, small opening or orifice. So escaping of air from a punctured tire, okay, an example of effusion. Orifice is nothing but the small hole you can see, uh, a point that is purposely made to for the for the removal of gases, that we can understand. Example is what? Escaping of air from a punctured tire, right? Football bladder also we can take. We can also take an example of escaping of perfume molecules. Okay, when you see the bottle of the perfume, there's a small orifice, right? When you press it, the perfume molecules comes out, right? That escaping of perfume molecules from that orifice or that small hole that we have, that process is effusion. Okay. So effusion is nothing but the escaping of air particles or any gas from a small orifice or opening. Okay. Diffusion. What is diffusion? You see, diffusion is the process of diffusion is the process of intermixing of gases. Intermixing of gases. Right? In this, what happens, write down. When the two or more gases, in fact, when the two or more gases intermix irrespective of their density irrespective of density and without any external help, without any external support, we can say, without any external support or help. Okay, so here we have, it's spontaneous, you can say, but effusion is what you see, effusion is under pressure. Okay, this is the basic difference between the two. Now when you press the the knob of that perfume bottle, through effusion the perfume molecules comes out, and when it comes out it diffuses into the air molecule. Do you understand the difference between the two? Mixing of gases is diffusion. Effusion is the leaking of gas from the small orifice. So when you press the knob of the perfume or deodorant, from the small hole the gaseous particles comes out. That is the process of effusion. And when it comes out, it diffuses into the atmosphere. And we get the smell from a certain distance, right? So that smell that we get at a certain distance, it is because of diffusion. But leaking of the gaseous particles from the bottle is effusion. Right? When you cook something in kitchen, right? The aroma of food that you get into the living room or your bedroom, that is because of diffusion. Okay, that is not diffusion. That is diffusion because the the smell that diffuses into the air particle. Right? I hope you understand this definition between the two things. Yeah. Now, obviously, two different processes we have. Effusion is something else. Diffusion is something else. But while doing the questions on this, the formula and everything is same for the two processes. There's no difference into this. Okay. So whether it is given diffusion or effusion in the question, you have to do the same thing for all kind of questions here. What is the formula? We'll see that. See this. Write down under similar condition. Under similar condition of temperature and pressure, the rate of diffusion or effusion, of gases are inversely proportional to the square root of their density. So we can write the rate of diffusion or the rate of effusion, whatever it is. Rate of diffusion or effusion is inversely proportional to the square root of density of the gas. Okay. So density is, directly proportional to molecular mass, because density we know it is equals to mass by volume. So for two different gases, if I write down the rate of diffusion or effusion at a similar condition, so we can write R1 by R2 for two different gases is equals to density of 2 by density of 1 and the square root of it. This is the formula we can use, which further we can write in terms of mass, that is the molecular mass of 2 by molecular mass of 1, square root of it. And molecular mass we can also find out with the help of vapor density, Vd of 2 by Vd of 1. Generally, vapor density we use when we have mixture of gases. So this is the relation, one relation of the rate of effusion or diffusion. Understood this? Okay. Yeah. Similarly, we can, how do we define the rate? Now you just keep it aside for a while. Okay, this relation that I have written, keep it aside. Now in general, I'm asking you, what is rate? Rate is anything divided by time. Like how do you define velocity? It is displacement per unit time, right? Speed is this distance travel per unit time, right? So rate of change of displacement is velocity. Rate of change of speed, sorry, distance is speed, correct? So whenever we talk about rate, it is per unit time calculation we have, okay? Now, if you talk about the gases, we can define rate by the volume diffused. If volume is given, that these many volumes diffuse in a given time, volume diffused divided by the time required for this diffusion, or we can also write the moles diffuse or effuse anything divided by the time required for this diffusion, or we can also write the distance traveled by the gaseous particle, distance traveled by the gaseous particle divided by the time required for this. Okay, just give me a second, somebody's there at the door. Okay, so this is the relation of rate we have. Because this density, molecular mass and vapor density thing you can write down always. This relation will write as per the information given in the question. Then this and this we can relate and we can find out the answer. Okay. You're talking about this one? Yes? This is the suppose rate of two different gases, right? At the same condition, same temperature and pressure. So R1 by R2 is the rate of one gas divided by the rate of the other gas is equals to the density relation, molecular mass relation, and vapor density relation, right? And for any gas, rate always we can define like this. It's not about the rate, anything we can define like this, right? For a given gas, oxygen, we say 10 milliliter of volume diffuse in 2 seconds, right? For example, we say a gas, any gas A gas diffuses 10 ml in 2 seconds, right? So what is the rate for this gas? What would we say? That the volume diffuses divided by time, that we say that it diffuses 5 milliliter per second. That is the rate of this gas. And this rate we can define, we can relate with any one of this relation, whatever is required. So sometimes in the question, they'll give you volume, sometimes they'll give you moles, sometimes they'll give you distance. So whatever the relation given in the question, you can take it here, and this, any one of these things, we can always relate with the molecular mass of the gas. I'll give you some question, you will understand that what is the point I'm talking about, but rate we define like this, okay? Now, suppose I'm taking for reference, suppose volume is given in the question, then there are two possible cases we have. This is possible with moles also, this is possible with distance also. So case one is what? Case one is when we have equal volume of gas, equal volume of gas diffuses in different times, like the t value is different, right? So what we can write for two gases, we can write R1 by R2 is equals to the volume diffuses for R1, V divided by time taken is T1, V divided by time taken is T1. Okay, this equals to, we can always write the molecular mass of the gas 2 divided by gas 1. This we can equate like this, okay? Since the gas is given, so you know the molecular mass, so you will have the relation of time, that is T2 by T1 is equals to M2 by M1 root over of it. This we can equate from this. Basic logic, you don't have to memorize this. Basic logic you can apply, you will get the answer. Suppose the second case we have just opposite of it. That different volume of two gases, different volume of two gases in equal time, means t value is same here. So suppose if we have R1 by R2 is equals to V1 is the volume divided by time t, V2 is the volume divided by time t is equals to, again we can write M2 by M1. This is equals to V1 by V2 is equals to M2 by M1 root over. This is the relation. Any doubt in this? Clear? Done? Okay. So this is the two possibility we have. Two more condition we'll see, which is not in general the case we get in the exams. But yes, if it is there, then what we have to do, we'll see. See, these two formula that we've seen till now is under the same condition when pressure and temperature is constant. Okay. What happens when pressure is not constant? Okay. So write down just two relation here. 99% of the cases you won't get this in the question, but yes, it is there, so you should know this. So if pressure is not constant, then we know more pressure, more will be the diffusion or effusion. Like if the pressure is more, then what we can write, rate is directly proportional to pressure. And we already know that rate is inversely proportional to molecular mass. This relation we have already seen. When we combine the two, we'll have rate is directly proportional to P by root M. And hence we can write, if pressure is not constant, R1 by R2 is equals to P1 by P2 into M2 by M1. Okay, this is the relation we have if pressure is not constant. So pressure is not constant, but here we are assuming temperature is constant. And we can also write next, if temperature is not constant, but pressure is constant. Pressure is constant. So more temperature, we have more kinetic energy, and more kinetic energy means more will be the rate of diffusion or effusion. So in this case also we can write rate is directly proportional to temperature, and again we already have this relation. So if you combine the two, we'll get rate is directly proportional to T and inversely proportional to M, and hence R1 by R2 is equals to T1 by T2 root over M2 by M1. Remember, this M is the molecular mass of the gas. So if the gas is mentioned, molecular mass is given. Copy this down. One second, Aditya. Madhav, which two equation you are talking about? No, we see, when pressure and temperature is constant, then it has no role. We have the relation before this we have discussed, right? It has no role, so we don't have pressure and temperature term over there in the expression. It's just R1 by R2 is equals to root under M2 by M1. That is it. Okay. Yeah, Aditya, for diffusion, we don't require any external support. Any external agent we don't require. Means the process of diffusion will happen without exerting any pressure, right? You see, I gave you the example, no? The aroma of food, right? When you cook something in the kitchen. we don't have any pressure. Once the molecules releases in atmosphere, after that diffusion takes place. So for that, the process of diffusion is what? It is intermixing of gases. See one thing here. For diffusion, we have two steps actually. If you take the example of perfume or deodorant, right? So once you press it, the molecules comes out. The molecules comes out is effusion. So once it comes out, after that diffusion takes place. Are you getting it? So for effusion, we require pressure. So more pressure, more will be the effusion, and hence more will be the diffusion. But for diffusion, we don't require any pressure because the process of diffusion is intermixing of gases. Are you getting it? Yes. Respond, please. Yes, we can say that. More effusion will be there, so more gases will come into the atmosphere, and hence more will be the diffusion. Okay, now we'll see some questions based on this. These two formula rarely we use. Okay, mostly they won't give pressure and temperature variable. Mostly they'll give these two as constant. So this formula that we have already discussed before this is more important here. This one, this formula is required. Okay, now we see some questions here. Try this one. Done. Yeah, that's right, Aditra. That's correct. Yeah, that's right, Aditya. Yeah. So simple one, you see, 50 ml of H2 and O2 is allowed to effuse through an effusimeter till the residual gas occupy 90 ml. Okay. So initial volume, you see, V initial we have is 100 ml. right? Residual gas means the gas which is left. So volume of the residual gas is 90 ml given in the question. So volume of effused gas is equals to what? Initially it was 100, 90 is present now. It means 10 ml has been effused. Okay. So we can write the rate of effusion of H2 by rate of effusion of O2 is equals to the molecular mass of O2, which is 32 by 2 root under, and that is 4. Okay. This is the ratio of the rate. Suppose X ml of H2 diffuse, and it means 10 minus X ml of O2 will diffuse. So we can write for the rate as X divided by the time required for this diffusion, and this time will be same for oxygen also, that would be T, and this is equals to 4 we have. We can solve this for X, and X you get from this is 8. Understood? Means the volume of H2 diffuse is 8 ml. Hence the answer for this question is volume of H2 effused is equals to 8 ml. Volume of H2 left, that is the residual, 50 minus 8, that is 42 ml. Volume of O2 effused, volume of O2 effused, that is how much? 2 ml. Then volume of O2 left is equals to 48 ml, and this is the answer for this question. Any doubt? Whenever you get this question of diffusion and effusion, only this you have to do. Take the ratio of rate, equate this to molecular mass and the data that is given here. See, here the data is given in terms of volume. We have taken volume. Sometimes what happens, they'll give you the number of moles here. So number of moles you have to equate with the volume. Clear? Understood? No doubt? Obviously, you see, for effusion, we must have the pressure difference. So the moment when the pressure becomes equal both sides, there will be no effusion. And effusion always happens when we apply pressure. You stop applying pressure, external pressure, there won't be any effusion. But condition, if you talk, when the pressure becomes equal both sides, then the gases won't diffuse. Okay, one more question you see. This kind of question they have asked in JEE exam. Okay, I'm not talking about the exact question, but exactly same pattern. Okay, data will be different. This one you see. Try this. Done? Yeah, approximately 81. Yeah, that's right. Approximately 81. Okay, you see the question is what? We have a cylindrical tube and the length of this tube is given, that is 200 centimeter. Okay, cylindrical tube, length of the tube is 200 centimeter. This is the two inlet we have here. This is X, for example, and this is Y, and this distance is given, that is 200 centimeter. Suppose this is X inlet and this is Y, and this distance from this point to this point is 200 centimeter. Okay. Now from this side we have HCl gas. We enter HCl gas from this side X inlet, and NH3 gas through the inlet Y, that is from the right hand side. NH3 gas we entered like this. At the same time, white fume first appears at point P inside the tube. Okay. So white fume is what? Suppose we have the reaction of NH3 and HCl. So when this NH3 and HCl reacts, this forms NH4Cl, and this reaction gives white fumes. Okay, basically white is smoke kind of things appears, which confirms that NH3 and HCl reacts somewhere here. Okay, so point is what? This white fume means NH3 and HCl meet at one point, and then only the reaction takes place, which gives the white fumes. Okay, so obviously both will diffuse from the two ends. Which one will diffuse more? What is the molecular mass of NH3? 17. Molecular mass of HCl is 36.5. Okay, so we know rate of diffusion is inversely proportional to the square root of molecular mass. Means we can say the rate of NH3 is more than to that of HCl. NH3 is more than to that of NaCl, and hence what we can say, NH3 will diffuse more than HCl. So suppose here the point P we have somewhere in between these two ends. Here we have a point P where the NH3 and HCl meets. So this distance I am assuming this as some distance. Suppose manlo it is what we can say, it is D, and this one is then 200 minus D, right? So this is D, so this is 200 minus D, and then we can apply the rate of rate equation here. We need to find out the point P from the distance X. So it means we need to find out D here. So what we can write, the rate of HCl by rate of NH3. is equals to, first of all, we'll write down the molecular mass of the two gases, 36.5 root under. And this would be equals to what? The distance traveled by HCl, that is D, time is same, that is 200 minus T. We can solve this for D, that will be our answer. Okay. So this is 2.25 and 2.25, the value is, we'll get here 1.5. Isn't it? D by 200 minus D. And when you solve this D, you will get approximately 81 centimeter. Answer is this. Any doubt in this? Any doubt in this? Tell me. In JEE, the question that they asked, they have given the question like this. They have given 3 points here in between within the cylinder. 1 point is exactly at the middle of this cylinder. 1 point is exactly the middle of the cylinder. 1 point is this side and other point is this side. And they have named this point, suppose P, Q, and R. HCl and H3. And the first question was that at which point, P, Q, or R, the white fume appears. What was the answer? What will be the answer here? You don't have any other info. At which point the white fume appears, ideally. How do we do that? This is the half of the tube, right? And we know the diffusion of NH3 is more than to that of HCl, right? In the same time, so obviously this NH3 will cross the half portion of the tube, half of the distance length of the cube of the cylinder, and NH3 will cross this side, and somewhere in this region, half of this region, this, half of this cylinder, this side of HCl, NH3 and HCl will meet because of the more rate of diffusion of NH3. Hence, the probable answer should be P, as the given information, as per the given information in the question. The answer is P. And then they have asked in the second part of this question that what is the distance from this end of P where the two gases meet. Okay. Yes. So this is the rate of diffusion and effusion. You will get some more questions on this similar pattern only. Just you need to equate and you will get the answer. Okay. That you will get in assignment. You can solve that. So next we are going to start the next part, the second part of this chapter, that is the real gas.